right, everyone, we're going to get started here. First off, thank you for having us back here at Devoxx. It's great to be back. It's part of one of the greatest developer conferences I know I've participated in. And we're very happy to bring back the Ask the Java Architects session to Devoxx. And so this is your opportunity to really touch the third rail and ask us questions. I know that we had a lot of sessions here this week covering a broad range of Java topics, things like Java 21 and specific features, which is great. Go watch those replays for a deeper dive if you missed anything. But this is your chance to actually interact with our architects, ask them questions. And if you're not familiar with an AMA, we do this over social. So break out your devices, your tablets, your mobile phones. Hopefully you're all on Twitter or sit next to some. Can I say Twitter? I can say that, right? It still says twitter.com. So I'm going to say Twitter. On Twitter, use the hashtag AMAJava. I'll be scrolling through those. If you're not comfortable posting it publicly, you can DM me. My handle is right there. I'll try to take as many questions as we can. But let me just introduce our esteemed panelists today. We have Viktor Klang, Brian Goetz. Is it Dr. Deprecator?
Dr. Deprecator.
Dr. Deprecator. Okay. I just want to make sure who you are today. Per Minborg and Alan Bateman. So let's go and get started because I already have a question, which is, wow, who was that? That's great. Let's do this. Is there a plan to have withers or builders in records? Who wants to take that one on? I think it's Brian.
Me, yeah.
Brian,
yeah,
I think that's yours.
That one's me. So the answer is sort of yes, sort of no, right? And a lot of questions, like this, posit a particular solution, and I'm going to talk about the problem, and maybe there will be a different solution, right? So the problem that they're alluding to is records are immutable, but you may want to derive a record value from a previous record value, just changing one or two of the fields. And so what people call withers are like the immutable analog of setters, which is take this object and give me a new object with x equal 3 or whatever. We certainly don't want to encourage people to write those as boilerplate methods. We just got rid of getters and setters. We're not going back there and saying, go write withers. So where we think this is going is something called reconstruction expressions, where you're able to deconstruct a record into its components, mutate those values, and then reconstruct the value back through the constructor, and it will look like something like point with x equal 3, which will expand to something somewhat more complicated, deconstruct the record with its record pattern, do mutations, lift the bindings into mutable locals, do mutations on those, and then the final values get fed to the constructor, which validates the invariance. So yes, the answer is there will be better support for mutating immutable objects. Records will be the first one, but we also have value types coming, and we want to be able to do the same with value types, so there's a story for that as well.
Well, there's a great segue question here, and so for Barry Van Summeren, the question that you asked is something we even ask internally, so I'm going to go ahead and put it out there. Now that Loom is done, Panama nearly done, and probably Valhalla too, what's the next big ticket feature item you are looking forward to? And I think that's pointed to all of you.
Sounds like we should go on vacation.
So Loom is not done. Not yet. We certainly got some of the features in 21, but there's a lot more to be done. I talked about it earlier today about a lot of the quality of implementation issues, working on monitors, working on performance. I gave a big list a list of items that we wanted actually to work on. We have to go and get more feedback of real-world usage of scope values and structure concurrency before we can decide how to make them a permanent feature, whether the solution we have is actually the right solution for the platform. And there's a whole bunch of other things that we still need to go and explore in that area. So Loom is not done yet, but I'll let others talk.
We're off to a good start, though.
Yeah, so I work with Panama, the foreign function and memory API. And the good thing is that we're going to finalize in 22. Big thanks to Maurizio and Jorn, who has been working hard with this. So when we work with this, we saw that we can add features just because it's final doesn't mean we can't add things. So of course, we thought about a lot of improvements there. So that's what I'm going to do the next half year or so.
So it sounds like Panama's not done either. So I'll pile on and say Valhalla's not done. But we have made amazing progress on Valhalla in the last year, and it's not very visible in terms of you're not yet seeing, the JEPs being filed, but like the Gordian knot that we've been trying to cut for the last year and a half in the Valhalla design process is not any of the hard technical problems of, what JIT optimizations can we do, but what object model can we present to Java developers that actually makes sense? And we have made just stunning progress in the last year and a half on this. And so we will see a bunch of JEPs being filed soon. That said, that's just the beginning of the implementation work, not the end of it. But like to answer what's next, well, I talked about Leiden yesterday. That's a project that's spinning up. Another project that's spinning up is Project Babylon, which is about programmatic transformation of Java code to enable things like, I want to write an algorithm in Java, but I want to run it on a GPU. Or I want to do things like LINQ lets me do in C#. I want to write a query in Java and have it get it turned into SQL. Or, I want to take a function in Java and I want to differentiate it, right? So all of these, the thing that's at the core of all of these is I want to be able to treat Java code as something I can analyze and transform and produce new code. And that's what Project Babylon is all about. And that's just sort of getting started. It's in its call for discussion right now.
Yeah, and I think the only thing that I can add here is that software is never done. That's the reality, right? So software only gets disused. So I think that we have a lot of interesting projects ahead of us, but I think done is hard to celebrate.
Yeah.
It's done until the next done is done.
So speaking of disuse, with my Dr. Deprecator coat on, the next big thing is things that have already been announced. Is the deprecation and removal of the security manager and finalization. And you mentioned a Gordian knot before. Disentangling those from the rest of the system is a real Gordian knot. We've been working on those since it's not a matter of just saying, oh, great, rip all the code out. There's a lot of work that has been done. There's a lot more work to be done. So expect some future JEPs to initiate the actual removal of both of those technologies.
Well, we got a little bit of a deeper dive here, and this is for you, Victor. I'm going to put you on the spot. You spoke about gatherers in your presentation. Why do we need these?
Why do we need this?
Yes.
So personally, I'm a huge stream fan. So I like the way that you can express transformations on top of data rather than doing it imperatively. So it's a way to offer almost everything without having to do it upfront. And I think that's always the challenge when you design an API. How do you decide what goes in, because it's going to stay there until Dr. Deprecator gets to it, and that might be a couple of decades down the line. So I think being able to express what you need is a good thing, because that means that we don't have to anticipate what that specific need was. So I think that's a sweet spot for gatherers and streams.
Can I just say, this is for those that didn't actually go to Victor's talk today, it's well worth actually watching the recording. Work through it. There's 60 slides, but they're all worth actually watching. There's some really, really motivating examples at the end of that, and I think people will really get it once they see it all coming together. So I thought that was actually well done. It's well worth watching that in the recording.
And it's a good illustration of one of our core stewardship principles, which is, if you don't know what the right thing to do is, don't do the wrong thing, right? So like the gatherers work, you could think of it as having gotten started 9 years ago when we did streams. There's a bug entry in the bug database from 9 years ago. SPI for adding new intermediate operations. And we knew that this was something people were going to want to do. We kind of wished we could have done it with streams in the first place. But boy, are you glad you didn't get the API that we could have given 9 years ago, because it would have been so much worse than than what Victor has cooked up. And so it's a good illustration of some things need to take more time to let the ideas sort of percolate a little bit. And very often there's a better solution hiding in there that just needs needs to be teased out.
All right, Brian, so this might put you on the spot a bit. Thank you for releasing Java 21. I guess you did it all?
Yeah,
Apparently
I guess so. No one told me.
What awaits in Project Amber, and can you talk about the on-ramp? I think that also came up in the booth a few times.
Yeah. So one of the cool things about Project Amber is that its sort of work list is infinite, right? And that's not to say that as Loom in Panama, there's always more work to do, but there is some hope that Loom might be done enough that we can stop calling it Loom at least. And Amber is explicitly not like that. There's a long list of things that people have asked for, some of which are good ideas, and we can't do them all at once, and so we're gonna chip away at them as we can. So some of the things that we're looking at right now, and I'm gonna have a whole talk about this tomorrow, so I don't want to get too deeply into it now, but there's more to the pattern matching arc. There is extending what we're calling record patterns today, but are really general deconstruction patterns to classes. And then there are the things that we can build on top of that once we have deconstruction patterns, like the wither expressions that I was just talking about, as well as a bunch of other things. And so there are still some obvious next steps there. And once we once Valhalla comes in, it will take all of about 15 seconds after you can discover that you can write new numeric types to wonder about things like, well, what about operator overloading? What about a specification of custom conversions from, say, half float to float and things like that? And so there's plenty to do on the Amber Parade as we go forward.
I'm getting a lot of questions on Loom, and here's a really good one, which is, what's the recommended way of handling back pressure with virtual threads?
Blocking queues.
Does that take care of it? You get your answer? Okay.
By the way, just mention is that the performance of some of the blocking queues, particularly things like the link transfer queue and synchronous queue with virtual threads, is absolutely wonderful in JDK 22. Doug Lee has actually done a big upgrade of that actually has optimized those for virtual threads now, and that's actually really, really nice to see.
And that kind of illustrates sort of how a lot of these big projects work, in that you see the big feature like virtual threads. What you don't see is all the work under the hood to replumb the entire JDK to identify every blocking operation and make it virtual thread friendly, you had to re-implement several network protocols to make it more virtual thread friendly, re-implementing some of the synchronization primitives. So there's a lot of ancillary improvements that a big feature like virtual threads is going to drag with it in its wake, which you might not be able to see and identify, but that fit together to be part of the whole experience.
Yeah, it's one of these features where we like to visualize as a house on stilts. It didn't originally start out on stilts. It had real foundations, but we had to jack it up and put it on stilts temporarily while we replaced the foundations. Then we need to figure out how to put the house back down again, where it was, without actually breaking anything. And that was what Project Loom was doing for the last 5 years.
Yeah. Yeah.
Okay, someone was just saying there were people living it. That is actually correct.
Yeah.
All right, this is a bit of
interior modeling at the same time.
This is a bit cheeky, but I'm going to say it anyway. Dr. Deprecator, where is Stuart? All right, with that, will there ever be a new revamped and sanitized collections API? That's actually a really good question.
Okay.
Yeah.
Maybe. In the deep dive session that Morris Naftalin and I did on Tuesday, which you can go watch the recording of, we did touch on this a little bit. People are constantly asking for new APIs, new sets of interfaces to deal with new things. And the difficulty is I think the main mistake that people do is they look at the structure of the APIs. This method doesn't belong here, so let's create a new interface. And I think that's the wrong way to approach it. I think what we really need to do is understand what semantics we want, what problems are we trying to solve, and so will there be a new collections API? Well, okay, what do you want that to solve? And if you're going to add a whole new set of interfaces to something that's going to be as heavily used as the collections framework is, and is intended to either augment or replace or supplant or something the existing collections framework, which is incredibly heavily used, then it better add a whole lot of value. And we don't know what that is. Maybe, and this is just maybe, the thing that is possibly the most likely candidate, and you can see me hedging here because we are not at all committed to this, but if we were to add persistent collections to the JDK, then that would probably demand a new API. Because I think it would be incredibly messy to try to retrofit that into the existing collections framework. So that would be something where it might provide enough value to have a new API. But we're not going to do a new collections API just to clean up the old one. If you've looked in my talks in the past, there are lots of weird edge cases, corner cases, inconsistencies and stuff, and I think we have to live with those, and we're not going to create a new collections API just to clean those up.
And I think there's sort of two angles that you can look at a library like collections from. So the first angle is the angle that most developers look at it from, which is I need a data structure to store my data, array list, hash map, what have you. And the idea of adding more collection types or a new collection API makes perfect sense of like, well, I've got 6 choices now. If I had 12 choices, I'd have more choices and more is better. But that's actually not where a lot of the value of the collections API comes from. A lot of the value comes from the other direction, which is the interfaces, set, list, and map, and where they appear in every other API in the world, right? And so if you did like a search over all the Java libraries in GitHub, almost every one of them would have list in its API somewhere. This thing returns a list. This thing consumes a list. And so let's say we decided it's time to have collections, 3.0 or whatever the next number would be. Now we have sort of bifurcated the world of collections, and we have devalued all of those old APIs that accepted or returned collections. We've made them harder to use because now either they have to be retrofitted or people have to have adapters and all of that. And so it's attractive to say, well, here's a data structure your collection frameworks doesn't have, and it doesn't, like bag, and it or graph. It doesn't fit neatly into the one you have, so you should make a new one. But the existing abstractions have a lot of value, even if you never create an array list. And that's that's the angle that we as platform maintainers look at it from.
I absolutely love these AMAs because it's literally like the hallway track in a session. So these questions, this is a very sharp bunch. This is a great question. With string templates, why do I have to use setter? Couldn't the default be simply to simplify concatenate to a string?
Yeah, so this is a question that's been asked by everybody in the first 5 seconds of looking at the design for string templates. And it would be nice if people thought about it for a few hundred hours before they asked that question, but they usually, the question escapes their mouth before that. So the question is, okay, you have this like cool string template feature, but I don't give a rip about string templates. I want interpolation, and clearly that's the important part of this feature. So why can't you just lop off the the unnecessary goop at the front of the expression and give me the real thing? Well, I think that's where this question is coming from, and the way I frame it obviously gives you a hint as the way we look at it is that string templates is about way more than interpolation. Interpolation is one of the things you can do with it. It's a useful thing to do. It's one of the motivating use cases for why we did it in the first place. But like if you look at a string template expression like str dot stuff in quotes, the important thing is actually the thing before the dot. That whole big thing is just a method call. The thing to the left of the dot is just a receiver. str is a static final field. It's an instance of template processor. And the stuff to the right of the dot is just a convenient way to write the method arguments. And so, like, if we look at a method call in Java source, printstream.println stuff, the important stuff is the part before the parentheses. That says what the thing does. The stuff in the parentheses are just the arguments, right? And so, a lot of people would like would like to get rid of this extra bit of syntax goop because it gets in their way. But we think that is sort of more of a moral hazard because if the only way that you think about this is that it's about string interpolation and you don't think about sanitization of inputs and and validation and transformation, this is a whole bunch of mistakes just waiting to happen. SQL injection attacks, cross-site scripting attacks, and so. Language design ideas that proceed from I want to type 4 fewer characters are more about writing code rather than reading code. We believe that reading code is more important than writing code. We want the code to be clear in what it does, and so we think having that extra bit up front is valuable because it tells you what's about to happen. So.
All right, Brian, they're really putting you on the spot. Does the book Java Concurrency in Practice still apply with Project Loom, or is it outdated?
So if we were writing it today, it could be shorter, which would be awesome. So I think Project Loom obviates the need for a lot of the tricks that are in that book, and that's great. There is room for new material, but for the most part, what Loom does is eliminates a lot of stuff that was hard and manual before, and I'm all for it.
Okay.
Sorry, Brian, what chapter dealt with cancellation and
Chapter 7.
delay? Yes.
Shutdown and cancellation.
Right. That'll have to be rewritten.
I'd like it to go away.
Structured task scope.
Yeah, structured task scope.
So we can expect another edition then, right?
Well, so I have this choice. I could make more Java or I could make more books about Java, and I think there's more leverage in the former.
Absolutely. This is a question we got a couple times in the booth, which is very good to call out. And thank you for whoever DM'd this to me. Preview features. Please explain why there are preview features and not just GA features.
I'm trying to understand why they think there's something wrong with preview features.
I think in the booth what we heard was, can't just preview features be released as a J quality feature when it's ready? What's the value of preview? And I think we talked a couple times of that, but for the general populace, we need to call that out.
Yeah, so the reason that we do preview features is twofold. One is we want to get feedback. We can think about things as long as hard and as hard as we want to, and we do. But at some point, there's always something we missed. And the only way to validate what we've done and figure out what we've missed is for people to use it in anger. It is relatively hard to get people to go download a early access release and try things out, in part because they don't always know when the right time to do it. They don't want to do it too early when the feature isn't fully fully formed, but they don't want to do it too late when things are already set in stone. So preview gives us an opportunity to say, we think this is the right answer. It's done. It has a specification. It's tested. It's production quality. But we would be willing to make changes if actionable feedback identified issues that require change. And with the more used to be that with 3 years between Java releases, there was a lot of time for people to to give us feedback on what we were working on as we did it. With the more rapid cadence, it's harder. And like a good thought experiment is, what if our release cadence was daily instead of every 6 months? Right? Is there ever a point where we go from Java doesn't have this feature to Java has this feature and it's permanent and final and will never change? We wouldn't want to do that in the course of a day. We want people to have a chance to give feedback. So that's why.
So I wanted to add something to that, which was even in the old 3-year releases, that was not enough time to get feedback. And even Java 8, I think was Java 9. But I think in Java 8, we spent a lot of time on streams and Lambda, and we got a lot right. But there are a bunch of things that are not right. And I think, I remember during that time, it's like, well, what if we did it this way? Well, have we gotten any feedback on this? And it's like, no. So I think the key is getting feedback, getting stuff into people's hands and getting feedback. Having multiple previews over the 6-month releases helps with that because those are in GA releases. And that did not even occur in the old releases, getting people to do the EA, download the EA builds and stuff. We did get some feedback, but boy, it's amazing. Even in a 3-year release cycle, there was not enough time to get feedback.
Yeah. Go ahead, Alan.
I'll also just say one thing is that we've been doing preview features and preview APIs now for a couple of years. And if you look at the history, there's actually been several features that have had adjustments. The FFM API went through more than a little bit of shimmer between its preview, and it's going to become permanent now, we hope. But it's the process of feedback actually works. And it is important for the ecosystem, for at least for those that are willing to put time in to try out a feature, is that feedback will be looked at. And if we have made a mistake and we are fallible, and there's time to fix it before the feature is permanent. So I think preview features have actually worked out, and they do, as Brian said, go hand in hand with the 6-month cadence.
And it's not just about feedback either. It's also an effective method of signaling what's that a feature has reached the stage where we're actually serious about it.
Yeah, that was one of the things that I was about to add. I think the biggest thing for me is expectation management, so you know what you expect as you try something out. And I think developing something in a vacuum typically means that you have to place your own judgment on the relative importance of each trade-off. And getting feedback allows you to calibrate whether you are trading off the right things based on what people actually use this thing for. So I don't see how you could really do it any other way and deliver good stuff over time. So I think it's super important.
Yeah, not only does it help us deliver a better final result, I think it also helps us deliver the result faster. So the feature that inspired us to do preview features actually was local variable type inference. The work for local variable type inference was done, asterisk, at the time Java 9 was ready. And we were very diffident about putting it in because there were a couple of annoying questions that we weren't sure we had gotten right and that seemed like they could have been big mistakes. In particular, it was the handling of capture types and intersection types. So we said, all right, well, let's give it a little more time. Let's see, if we get any good feedback. And then we got, 6 months later, to Java 10. We hadn't gotten any feedback from the community on it. And we still were just as unsure as we were in Java 9. And so if we didn't have a vehicle for putting it out where we could get more feedback, we might have kicked the can down the road from 10 to 11 to 12 because at each point we still hadn't figured, we hadn't gathered enough information to know which way to go on this actually minor part of the design. So it gives us an opportunity to get things out there, earlier.
And I think also another good thing with previews are that they also work in the other direction, because we see for example, FFM API that many libraries is actually implemented solution that relies on the new API, even though it was just preview. And if you just put -- enable preview, those functions will be automatically enabled, and that also enables users of that third-party libraries to try out the features. So we'll get a much more broader footprint of actual use.
And let's take that a step further too, because it's not just preview features, but our early access builds too, because we're trying to accelerate productivity at the time that we GA. So you have the opportunity in advance. I mean, we already have early access builds of 22 available as we speak. So this is your opportunity to give us feedback to course correct and do that fine tuning and adjustments that are necessary before we reach March of 2024. Okay, another question. This is coming from, I guess, the keynote. And Jan, thank you for the question. Brian, you announced the VS Code plugin with the Lisp server yesterday. When it's released, will I be able to download the Lisp separately so I can use it in other editors?
I am not sure, actually. I mean, the package that we have now is is packaged as a VS Code extension. I don't know how much work it would be to extract it as a general purpose LSP server. Maybe it's not that hard.
By the way, it's not Lisp. It's Language Server Protocol. LSP is, I think, is what what this person was
Yes,
saying.
I do acronyms, man.
Okay.
All right, next question. And this is coming from, I hope I pronounced this right. Where'd it go? Here we go. Kion? Why doesn't the garbage collector run during the JVM idle time when memory isn't close to max heap size? It will give devs more insight into how much memory their app actually needs. We haven't had a garbage collector talk or question in a while, so we could take that any way you like.
So I'm not sure that it doesn't. Is he sure that it doesn't? I mean, the garbage collector, modern garbage collectors are concurrent, which means that there are garbage collection threads that are running at the same time as the application. If the application threads aren't using any CPU, that means there's more cycles available for the GC threads to run. So I'm not sure that it doesn't already work that way.
Okay. Rex, will it ever be possible to optimize or restructure the way Java classes are structured in memory?
What do you mean by restructured?
Such as C-sharp's struct layout attribute.
Okay. This is where's Valhalla, right? Yeah. So the question is, the way objects are laid out in memory today is that a reference to an object is always represented as a physical pointer to some block of memory that has an object header sitting in the front of it. Object headers are between 4 and 16 bytes, depending on which runtime you're working on, and that means a lot of memory used up by headers and a lot of indirections in memory access. Dependent loads are expensive. C# has a language feature, VM feature called structs that allows you to embed one object inside of another and eliminate those indirections. And this is one of the main features, although slightly different from the way C# does it, of Project Valhalla, which I talked about a little bit earlier, as coming real soon now.
Alan, do you have something to say too? Good. All right. What's the reasoning behind naming the sequence collection methods get first, get last, and not first and last?
Okay. All right. So naming is an intractable problem.
Is Stuart here?
Yeah.
All right.
Yeah.
Yeah, take the coat off.
Okay. Naming is an intractable problem. And unfortunately, if you look across the collections framework, the naming is not particularly consistent. There are a bunch of inconsistencies here and there. And I don't, I'm sorry, I don't actually have all of the APIs memorized, but I think if you consider, say DEC, and prior to JDK 21, if you look at DEC and sorted set, I believe sorted set has first and last, and DEC has get first and get last. And so one of the constraints that I decided on fairly early in that design is to reuse method declarations where possible, because if you introduce new things in order to fix the naming, then what that does is it ends up, those get inherited everywhere, and you end up having redundant methods. So I wanted to reuse declarations. I think DEC was the nicest because we have this very nice API. A set of operations, which is get, remove, and add, and first and last. So you get this nice cross product with 6 operations that do the things you want to do, and those don't exist on sorted set. So so I decided to take those set of operations from DEC and promote them up to sequence collections, where everybody can inherit the entire complete set.
Got a performance question. So quite some performance work has been done in I/O and NIO. How do you select which area to look at for such work? I think, Perry, you may have done some work in that area?
Yeah, so we took a look at some of the really old classes, like a random access file, for example. And we discovered that there were quite a lot of things that we can improve there. This class has been sitting around since Java 1.0, yeah. And we were actually able to improve performance by a factor of 6 using long operations, and maybe a factor of 3 for int operations, and maybe almost double for short operation. I think that's great to be able to also pay some attention to the old stuff that just sits around there and not just only focus on new features. I think that's a part of a responsible stewardship of the platform. So I think that, and the good thing also that random access file is used transitively by a lot of other classes in the JDK, so they also got faster. For example, serialization is now about 12% faster without any code change. So I think that's great. You get that for free. I mean, that's 0.2 more cycles almost. So ain't that good?
This will probably be a different perspective for each of you, but which thing about Java would you like to fundamentally change, but is not feasible because of backwards compatibility?
Can't say serialization.
Damn it!
All right, for the recording, Nikolai shouted out, "Can't say serialization," and I think that was at least Brian's and my answers.
It's a long list.
It is a long list.
All right, I have one, and it might get solved, which is this idea that I mean, the original design of Java is every object has a monitor, and the idea is that every object should be made thread safe by making its method synchronized, and you see that embodied in the very early class libraries like vector and hashable. It's like, oh, we can make a thread-safe collection by making every method synchronized, and that whole aspect of the language and library design is just wrong.
I think another way was that we got pretty much everything wrong from the beginning. So when we declare a variable, you can mutate it. When you declare a class, you can override it. So set in the retrospective view we have today, we would have done it the other way around. But I think it might be the right thing at the time, because at that time, there were other paradigms prevailing. So I think it might now appear as the wrong choice, but maybe it was the right choice from the beginning. Otherwise, Java wouldn't be where we are today.
It's kind of amazing how Java has been so successful, having gotten arguably all the defaults wrong. Yeah. Right? Mutability, extensibility, monitor by default. Serializable. Got all the defaults wrong. Yeah. It's not serializable by default, but you're just gaslighting me now.
I think that's sort of different, though. Oh, sorry, but because though it took decades for everybody to realize that those defaults were wrong.
Yeah.
And probably Java would not have been successful if everything were immutable from the outset. People say, "Oh, why do I have to? Of course, I want to change this. Why do I have to declare that every time?" So I think your point is some decisions in retrospect are now the ones we do not want, but at the time they were made, they were the right ones. But I think the thing about the monitor locks and classes having synchronized methods everywhere proved to be a failure very quickly. And in fact, so we had to, the evidence again is vector and hashable, because we replaced those very early on. I mean, so with the collections framework, most of which was unlocked. And the idea was that you have locking at a higher layer, or you use higher level data structures, as we determined from the Java 5 concurrent collections. So anyway, so I would make a stronger case that was an early mistake that was realized quickly.
I can't keep a straight face when Stuart says hashable. But there's quite a list in my head. But one I would put near the top is set accessible, which is, we might think about it as something that really helped the ecosystem and was beneficial for a lot of libraries. But here we are in 2023 and trying to upgrade some of these older applications and trying to move with a new release every 6 months. Set accessible is holding us back. there are so many libraries that have been hacking into the JDK for good and bad reasons. And because a lot of these libraries aren't maintained, or they haven't actually migrated to making use of newer APIs, then they're causing problems for a lot of upgrades. And we're actually seeing this all of the time now for people that are finally making the leap from JDK 8 to 17 or even 21. So I put up there as one that it's unfortunate.
And this is just a minor one, a personal one. I think use site variance is one of those things that I would have done it differently. Just keep it closer to the implementer. But yeah.
About the use and abuse of set accessible, you say that yes, sometimes it's 90% of time probably is an abuse, but sometimes it's something legit that people is trying to do and cannot do because the API is closed. Do you from time to time check how people is using set accessible and decide, okay, maybe it's time to open this field?
Do you want to repeat the question?
Yeah, I'll repeat just for the recording. I'll just repeat the question. So what Mario asked was about set accessible and whether we've actually ever done any analysis to see why they're actually used. Because 90% of this is probably bad in quotes, but there's another 10% is that might have been used historically because of the lack of some APIs. So the question is how have we ever figured out what new APIs? And there's actually quite a list that we've actually added over the release. A colleague of mine, Mandy Chung, and I, we spent quite a bit of time in the JDK 9 timeframe working through the top uses of set accessible to see why are people actually doing certain things. One that came up at the time was things like there's a protected method on class loader called define class, and there was a whole bunch of libraries that were actually making use of that to be able to inject classes into packages. So we actually added something in the 9 timeframe to method handles lookup, which is a proper control safe defined class to be able to actually to put a class into the same runtime package as lookup class. There's actually about a dozen of those that I've actually that we've actually added, because a lot of these things tend to be more performance reasons or something like that. So we have done quite a few. The one thing I will say is that the maintainers of some libraries are actually quite slow to show up in the OpenJDK mailing lists with requests for things. There's been a couple of occasions over the years where people have shown up and it's like, oh, this is crazy. This breaks the whole integrity of the system. We can't do this. There's other things which actually have led to discussions and actually have led to figure out what's the real need here. Why is actually doing this thing X when it's really what's missing over here is Y. So what I would encourage libraries to do is if they feel like, I will say there's another part to this, which is, and maybe this isn't the bad part, is sometimes there's a sense of entitlement in some of the libraries out there, in that they spot something in the JDK code. Oh, JDK has this privilege operation I can actually use over here. I will make use of that, and suddenly my code goes 10 times faster. But there's a whole bunch of assumptions as to who's using that code, and then now suddenly we've got all these other kind of issues in there. So all I would say is encourage maintainers of libraries. They're typically kind of doing advanced type of things to come up with a case for what the real issue is in here, and would it make sense for there to be a standard API for something in this area.
Thank you, Alan. Here's one question that is summarizing several questions that I'm getting, which is all around how is Java addressing AI?
That's actually like 19 questions.
That's right.
So
well, 6 according to the feed, but absolutely.
Yeah. So the way we look at this is we want Java to be a good platform for all the different computing things that people want to do. And five years ago, 10 years ago, AI wasn't as big an issue as it is today, but we had, one of the hot things, 10 years ago was big data. What's Java doing for big data, right? And we look at these pain points and we say, how can we make the platform better? And the thing that comes from that process is projects like Panama, and projects like Valhalla, which are, at the underpinning of why things like big data or machine learning in Java is more difficult. And so the way we look at this is we want to make Java a hospitable place to do AI work. We don't necessarily want to provide a neural net training API in the JDK. That's something that can be done by people who actually understand machine learning. But what we want to do is provide the platform underpinnings so that they can write an awesome library. And so, we're focusing on things, Panama and Valhalla are the first part of the story. There are other parts of the story, like where's the equivalent of a NumPy, which is something we can start thinking about now that Panama has delivered some of the underpinnings. And so there is an AI story, but it's not about AI, it's about AI enablement. And at the same time, when you look at, when you talk about AI and computing, do you mean training models? Or do you mean running models in production to do inference? And we don't really think that the former area is a very high leverage place for Java to try to gobble up, because that tends to be much more of an ad hoc experimentation oriented environment that there are good tools for now. But Java is the language for enterprise application deployment, and as enterprise applications increasingly make use of inference in their work, we don't want them calling out to some janky Python in a container thing to do the work. They want
Brian Goetz just said janky.
we want that to be something that there is good first class library support for online inferencing.
And also, I think I can add that already today there is something called JExtract, which can generate bindings for calling native libraries, and you can literally be up in minutes and generate a kind of thin wrapper around Java code and any native code, and then you can invoke it in pure Java. So if you're interested in that, you can go to the early access and try it out today.
Yeah, so if you want to use TensorFlow, you can wrap a Java API around it using JExtract.
Yeah, and you can just invoke the methods as they were seen as C.
Yeah.
And you can just provide Java parameters and all that stuff, and you can use them directly. Yeah. So that with good performance. So that's great.
Yeah, I kind of like this to kind of close out on this Ask the Experts. So first off, thank you to all of our panelists. We've had a lot of technical questions today, but we have here one that's focused on career. And we know conferences are a great place to actually upskill ourselves. What's your opinion on how to improve bridging the gap between junior and senior developers in the community? I'm going to start a little bit with that. If I could ask, if you are part of the Java DevRel team at Oracle, could you stand up real quick? I know there's a couple of you in the room. There's one. I thought there was two. There should be three. Please follow these individuals. Come meet us in the booth. These are the people to help you bootstrap your career. At the bare minimum, please visit dev.java. It's one of the easiest URLs out there, dev.java. We have a catalog of learning material touching on every skill level from beginner, intermediate to advanced. But more importantly, let's take advantage of the community. I know some of you are here. Coming in person to an event like this is a great way to make a connection. But you have over 360 Java user groups. Is anyone not a member of a Java user group? Not a member. Raise your hand. And it's okay. There's no shame. That is a great place to actually bootstrap your career and learn from others, because that's where knowledge transfer happens. That's where best practices are shared. That's where use cases are expressed regardless of industry. So if there's anything that I can encourage in terms of going from a junior state to a senior state, which by the way, my father had a great quote, junior and senior are both 7 letters. And what that meant to me is there is no difference. All of us have value that we're aspiring to become better at, but just remember, the title is irrelevant. The expertise that you gain is important, and we can do that collectively. And I was just curious if any of you had some advice from a career standpoint, because you're all technically still learning.
Right, okay. Let me try to formulate a quick soapbox in about one or 2 minutes. I think that learning is extremely important, and you have there's a management problem, I think, with a lot of software development projects where The emphasis is to crank out the code and get it out the door and move on to the next thing, and not actually solve problems and not learn. As a junior person, if you find yourself in a position like that, then the way to manage your career is to find a position where you can learn and where you can develop. And if you find yourself in what is essentially a software sweatshop, then you need to take the steps on your own to get yourself out of that and into a better position, and find and seek out mentors and managers who will support development, your professional development.
It's great advice, Stuart. And with that, great place to start on everything technical, everything career. Go ahead, screenshot this, bookmark this. We want you to visit our portals. We've tried to aggregate all of our information as best as we can for you for that learning experience in multiple areas. More importantly, please stop by the booth. All of our panelists will be there at some point. Continue to ask the questions. And with that, let's give a round of applause to all of our panelists today for this Ask the Architects.